Hi everyone, welcome to my video tutorial on recursion in C programming. I am Lorenz, Cerico, and for this video, we are going to explore what recursion is, how it works, when to use it, and how to write recursive functions properly. Our learning objectives for today is by the end of this video lesson is you will be able to number 1 is understand what recursion is and how it works, number 2, write simple recursive functions in C, number 3, trace and explain the flow of recursive calls. First and foremost, let us know what is recursion. Recursion is the technique of making a function call itself. This technique provides a way to break complicated problems down into simple problems which are easier to solve. Think of recursion like looking into two mirrors facing each other. You see reflections within reflections, or imagine a Russian nesting doll, where each doll contains a smaller version of itself until you reach the smallest doll that doesn't contain anything else. A recursive function has two essential parts. The first one is the base case. This is the stopping condition. It tells the function when to stop calling itself and return a direct result. Without a base case, the function would call itself infinitely, causing a Stack Overflow error. Number 2 is recursive case. This is where the function calls itself with modified arguments, moving closer to the base case with each call. Why do we use recursion? Simply, it is because recursion makes code simpler when you have repetitive patterns. Instead of complex loops, you just call the function again with a smaller value. It's perfect for problems like factorial, Fibonacci, or searching through folders, problems that naturally contain smaller versions of themselves. How it works internally. Every time a function calls itself, the computer creates a stack frame, like stacking plates. Each plates store the parameter values, any local variables, and return address, so it knows where to come back to. When the base case is reached, the stack unwinds. Each function returns its result and disappears one by one until we get our final answer. For our first recursive example, we are going to create a function that calculates the factorial. So, int factorial then curly braces, and this is our base case, in which the base case is the stopping condition. So if n is equal to 0 or n is equal to 1, parenthesis, curly braces, and then we are going to return 1, then another curly braces, and this is our recursive case. Here the function calls itself, so else return n multiplied by factorial n minus 1, then semicolon. So we multiply n by factorial of n minus 1. So the factorial of 5 equals 5 times factorial of 4, and so on. Each call waits for the next one to complete before calculating its result. So next one is int name, then curly braces, and then let's calculate for the factorial of 5. So int number equal to 5, semicolon, and then we call our factorial function that stores the result. So int result equal to factorial, and then number, and then semicolon, and then finally we are going to print the result. So printf factorial of d is \n, then number result, and then parenthesis, semicolon, and we are going to return 0. Then let's run. So the output is factorial of 5 is 120. So this is correct. Another classic example is Fibonacci, in which each number is the sum of the two numbers before it. So let's start. So int Fibonacci int n and curly braces, and this is our base case, n is equal to 0, and curly braces return 0, semicolon, and then another curly braces, and then this is our second base case. So if n is equal to 1, then curly braces return 1, and semicolon, then the curly braces. Then this is our recursive case. So else curly braces return Fibonacci n minus 1, then parentheses plus Fibonacci n minus 2, and then curly braces, and then another curly braces. For any other number, we calculate Fibonacci of n minus 1 plus Fibonacci of 2 of n minus 2. Notice this function calls itself twice, once for each of two previous numbers. Then we add those two results together, and then int main, then curly braces. So let's print the first 7 Fibonacci numbers. Int terms is equal to 7, semicolon, then printf int Fibonacci sequence is up to d terms backslash n terms and semicolon. Then we are going to use loop to calculate and print each Fibonacci number. So for int I is equal to 0, and then I less than terms, then semicolon I, and then increment, then curly braces. So for each position I, we call Fibonacci and print the result. So print f d, then Fibonacci I, and then return 0, and then another curly braces, and then okay. So the Fibonacci sequence up to 7 terms. So notice that each two numbers before it is the result. So 0 plus 1 is 1, 1 plus 2 is 3, 3 plus 5 is 8. So that is our example for Fibonacci sequence. Many people often make these mistakes with working with recursion. Number 1 is forgetting the base case. If you forget the base case, your function will call itself infinitely and crash with an stack overflow error. Number 2 is inefficient recursion. Some recursive functions like Fibonacci recalculate the same values multiple times, making them very slow for large inputs. Number 3 is stack overflow. Too many recursive calls can run out of stack memory, so consider using iteration for very deep recursion. Number 4 is missing return statements or not returning values. Always remember to include the return keyword before your recursive call, or you will get incorrect results. To avoid these issues, always define a clear base. Make sure each recursive call moves closer to it, and test with small inputs first. For your challenge, to test what you have learned today, your task is to create a program that computes the sum of first and natural numbers. These are the guides. So, first is take input from user. Second is pass the input value to a function. Third is inside the function, check if the number is equal to 1. Fourth, if true, return 1. Fifth, otherwise return the number plus a recursive call to the function with parameter 1 less than the number. For our question today, which of these following statements is false? Comment down below your answers and let's see if it is correct. In conclusion, we covered what recursion is. It is a function that calls itself to solve a smaller problem. We learned about the two essential components, the base case that stops the recursion and the recursive case that breaks down the problem. We implemented two classic examples such as factorial calculation and the Fibonacci sequence, and we discussed common pitfalls like missing base case, inefficient recursion, and stack overflow. If you found this tutorial helpful, please like, share, and comment down below. Let me know which C programming you'd like to see next. Don't forget to subscribe for more C programming tutorials. Thank you for watching and happy programming.